Hello and welcome to the first episode of our Let's Make Sensix of series. I'm Lucian and Corduneanu, Sensix co-founder and CEO, longtime software developer and IoT enthusiast. Making Sense of is the first episode of a series aimed to make businesses environmentally friendly and aware of their energy and ambient practices. If you are a manufacturing company manager, a facility administrator, a real estate developer, or maybe even someone who is really interested in energy efficiency, climate change, and sustainability through technology, this is for you. But first, I'd like to introduce you to what Sensix does and why we want to make Sensix out of various topics. Sensix is a complete IoT solution that provides ambient and energy insights for industrial facilities. To find out more about our work, you can visit our website sensix.io. And now let's get to our main topic. Today we are making sense of energy efficiency. I'd like to wish a warm welcome to our guest, Gheorghiu, PhD teaching assistant at University Polytechnica at Bucharest and energy engineer. Welcome, Cristian. It's a great pleasure to have you here.
Hello, Lucian. First of all, let me make a correction. I'm still a PhD student, but
All right.
I'm on the final path of getting the full PhD. Regarding your question, I chose the energy efficiency side of energy engineering, as I think that the fight against climate change and uh, the responsibility to decrease our impact on the environment is is a target that each one of us should have. So I decided to make a career out of it.
Very
In
nice.
that direction, I chose energy engineering as a main topic because, as we all know, the one of the most significant environmental impact as of right now is related to energy use in all of its form, starting from electricity, going to thermal energy, um, fuel for transportation, etc.
Mhm.
Every sector uses energy to function, and most of that energy generates an environmental impact. Energy efficiency as a topic is a rather large topic in the sense that it covers various aspects of all economic sectors around us. Each sector is subject to a potential of improvement in energy efficiency. And as the fight against climate change becomes a priority throughout the world, and especially in the European Union, energy efficiency has became already a top priority for all state members in the Union, uh, as the European Green Deal
Yeah.
has been approved at the end of last year.
So,
So
so that I get it straight, is it the main aspect that you are interested in is that like climate change, climate impact? So that's your main drive?
E- exactly. That's my main drive, and the best way to fight against climate change is to fight for energy efficiency.
Yeah.
Improving energy efficiency is one of the best ways of diminishing the environmental impact of every single type of industry.
Mhm.
Obviously, the second direction and the second topic that also leads to a significant reduction of the environmental impact is the greater penetration of renewable energy sources.
Yeah.
So these are the two directions that us as a society must follow in order to make sure that we have a place to live tomorrow.
Yeah, regarding renewables, there's an entire topic about this, of course, but it's a bit counterintuitive that nuclear is the way to go in some lines, right? I mean, it's more efficient. What's your opinion about this?
Yes, as you've already stated, it's quite a topic. Nuclear energy is indeed, from the point of view of fuel, uh, almost non-pollutant sector
Yeah.
of the energy production topic. But there there are obvious issues with what do we do with the remaining nuclear fuel after we've used it in our power plants?
Yeah, that's true.
There are I think 4 or 5 companies that have already proposed a new type of nuclear power plant, which are modular nuclear power plants, small size, better security, modularity. These could be the future for big industrial users who either don't have the required surfaces to install, for example, photovoltaic power plants, or operate in an environment which is heavily polluted, which in turn could lead to worse profitability for a conventional renewable system, such as photovoltaic, as I've
Mhm.
already mentioned.
Yeah, I see. So
Yeah.
maybe you can tell us a bit more about the role itself. I mean, what's the role of this energy efficiency, like a subject, let's call it, in the fighting of climate change?
So, okay, as every nation on Earth is in a continuous race to improve and enlarge its own economy by pursuing an economic growth. This is obviously correlated with the higher industrial, agricultural, and transportation sectors. So the more advanced the society is, at a point in time, the more resources it uses. Um, in this sense, we can take a look at developing nations such as India, such as some countries of Africa, most countries of Asia. As we can see on a CO2 world map, these countries are the biggest pollutants at the moment. This obviously comes from the fact that the demand uh, is
The demand for
much
energy, right? Yeah,
not necessarily the demand for products, for
for products.
services
Hmm.
is much greater than the available offer. So the providers must use every little bit of resources to uh, keep up with that demand. So they can't care. It's not that they wouldn't like to care, but they cannot afford to care about environmental impact, about pollution. They have to build and to provide the required products and services in order to keep the economy on a
Yeah,
roll, because otherwise it's a recession and nobody wants that.
yeah, of
So
course.
energy efficiency as a topic, as a concept, comes to aid these developing countries, and not only the developing countries, but also advanced advanced from an economical point of view countries, in order to diminish this impact while still maintaining a high productivity. How can we do that? Well, that's simple. As long as we keep the productivity as a constant, the only way to diminish the environmental impact is if we use less resources. So that's what energy efficiency basically is: maintaining the constant productivity while using less resources. We can do this in a in a lot of ways. Actually, we can improve our technological process. We can modify our technological process. If we talk about an industrial end user, for example, we can adapt our business models. If we are talking about the tertiary energy sector, such as commercial buildings, office buildings, etc., as long as the economic indicators at the end of the year are kept the same or even improved, anything goes as to what can we do to improve our energy performance, thus
Yeah.
obviously reducing the environmental impact.
Okay, so they are hand in hand, obviously. But the question is, if you really like try and find ways to be more efficient in energy usage, right? Um, isn't that also a way to consume more? I mean, if you are more and more efficient, there is more and more and more demand, right? I mean,
Yes,
how do you?
unfortunately, that's the other side of the coin. There's a study made by a couple of renowned professors from the USA, which coined that term, which is the Nissan Leaf effect. they noticed that contrary to what they expected, when citizens from the USA bought cars produced in South Korea or Japan, which have a considerably less fuel consumption there than the average American car, instead of quantifying that decrease in consumption per 100 miles in an annual decrease of consumption in fuel, the citizens ended up using the car much more often than before because it cost them less.
Yeah,
So the
could be
overall
like a
effect,
paradox, right?
exactly. The overall effect was smaller than expected in the first stage of the study. Yes, that is indeed a not a problem, but a point of view. On the other hand, this could only also mean that with the same amount of energy used, we could end up increasing our productivity, because in the end, as I've already said, the main goal is to continuously improve and continuously increase our productivity, our economic growth.
Yeah, of
But
course.
on the other hand, the fossil fuels and most of the natural resources are not infinite in quantity. And furthermore, some of them are highly dependent on the geographical region of the business.
Yeah.
So if we could use them more wisely and extract them more wisely and transport them more efficiently, overall, we could also get an improving productivity with the same costs.
All right. So yeah. Obviously, that's a very tricky subject and interesting topic as well. But regarding this like way of improving, right? So if you have a way to identify some performance improvement actions, let's call them, what would an energy audit do for this to happen?
Yes, that's a good topic that you've chosen. By definition, the energy audit is the process that allows either a company or a individual to assess the performance with which resources are used, energy resources, of course. The process of energy auditing a company or an energy boundary, regardless of what we find there from a legal point of view, consists in a number of steps. The first step is to do a preliminary energy audit, or a walkthrough audit, as it is called in the technical regulations. And in this stage, the energy auditors practically go and take a stroll to the energy boundary in order to visualize, understand the technological process or the energy flows inside the energy boundary, and it can lead to the identification of no cost or small cost energy performance improvement actions.
Yeah, and can you give us some examples, for example,
Oh,
on low cost? Everybody
of course.
is like, okay, so what
Exactly.
no to low cost measures can we take so that we can be more efficient? So please
Exactly.
tell us.
Exactly. That's that's just the case. A couple of low cost examples are the replacement of existing lighting system, the installation of variable speed drives for electric motors, the reparametrization of the control unit for the heating, ventilation, and air conditioning system. These are low cost energy performance improvement actions. Of course, um, this type of categorization, low cost is a relative term. What may be low for a company might be high cost for another one, and vice versa. So it all depends on the specific type of industry that is audited, the specific type of client that is audited, because that is also true. Not all clients are as inclined to actually implement those energy performance improvement actions from various motives.
Yeah.
Some examples of no-cost energy performance improvement actions are energy labeling, putting up labels prompting workers to, for example, the classical turn off the lights when you leave the room. That is an energy performance improvement actions. And that is mainly due to the fact that not only technology uh, exerts a direct influence over the energy performance of an energy boundary, but the consumer behavior component does that too. If in a process, the way in which the consumer, as it is defined, respectively the user, the personnel of the company, the client of the company uses that energy, then it has a direct influence over the overall performance of the company. That component can be educated, but in order to educate the consumer, the employee, the employer, why not, we have to continuously invest in education. And that is one of the main issues in today's society. It's on one hand an issue, but on the other hand, it's a trend. Newer generations are coming in hot from behind and are much more dedicated to to the fight against climate change, and thus they can educate older generations into understanding the problems this trend generates,
Yeah.
and how can we all fight together against this situation.
Maybe do you have like a kind of a success story in which after you perform some audit to a company or to a client, some measures were taken into consideration, even if they were not really low cost, but maybe high cost, that tremendously improved the efficiency
Absolutely.
and by that hopefully and indirect or direct the climate impact. That is,
Absolutely.
by the way, maybe you can also discuss about how do you measure, how do you quantify that climate impact,
Yes, sure. I have a number of examples. I'm gonna stick to only one, which is the most recent one. It's a commercial center, quite large commercial center.
Mhm.
Um, I have audited this client at the end of 2020. And after the whole energy auditing process, me and my team identified a number of possible places for energy improvement. And these systems actually were the heating and ventilation system on one hand, the way in which the lighting system was used on the other hand, and the fact that they, regarding the environmental impact that you've also mentioned, they had a significant amount of rooftop surface available for installing photovoltaic panels, which they didn't use up until that point. So during the energy audit, we we identified the fact that they didn't have a proper energy measurement system. This is another topic that we'll have to cover in our discussion today, because from my experience, this is an issue that is, I'd say, even the most common encountered issue. Most of the industrial end user and almost all of the commercial end users don't have a proper energy measurement system. They only measure energy in the point of common coupling, as it's called in technical terms, which is the point, or most of the time is also the point at which the billing measurement system is installed. So in a more familiar language, they measure energy at the fence. They don't know what happens to the energy inside their own energy boundary. And this is a problem, both for them and for us as energy auditors, because we cannot properly identify the energy saving potential of a subsystem if we can't measure its energy use for a relevant period of time. During our energy audits, we tend to bring our own measurement equipment, portable power quality analyzers, for example, portable thermal imaging equipment to evaluate the performance of thermal isolation. And for this client, the situation was also the same. They only had a energy meter at the point of common coupling in the transformer post which powered up their internal distribution grid. And they didn't knew how well or how badly their heating, ventilation, and air conditioning system really worked. So we proposed them to install one of those portable power quality and energy analyzers for a relevant period, which we consider to be a full week. But in fact, if you really want to be thorough, you would have to measure for at least a full year, if not more. We'll come back to that idea. We measure the electrical parameters, both energy-wise and power quality-wise, and identified the fact that the system was, on one hand, not properly set up in the sense of operational parameters, and on the other hand, it was severely oversized with respect to the required cooling power needed, because the client 2 years ago implemented a complete remake of the thermal isolation of the building.
So and they had some expectations, right?
Yes, and they didn't take into account the fact that by remaking the thermal isolation of the building, the necessary cooling power and heating power would significantly drop. So they ended up with getting a better performance in the overall thermal behavior of the building, but with two oversized pieces of equipment, the thermal power plant and the chillers of the heating, ventilation, and air conditioning system. So we proposed that they replace the chillers, as they were already old enough, older than the regulated 12 years as per the Romanian legislation. So from an accountable point of view, they were already covered. So they did that, and also we told them that they should invest a little bit more money and buy a chiller system which has a variable speed drive, in order to ensure the fact that if the required cooling power varies over time during the hot season, obviously, the electric power can follow that demand curve of the cooling power. By doing so, they managed to drop their electricity use by 8%, with an investment of about 80,000 euros. So that percentage that I've mentioned before amounted up to 23,000 euros per year. They got their money back in less than 4 years. So that was great for them. Yeah. Another thing that I've mentioned, we've recommended them to install photovoltaic panels on the rooftop. We've identified a financing source for them, and we've helped them with the feasibility study that they had to draft up for the funding entity. They got the money, they installed the system. The system had a peak power of 200 kilowatts. It's not much, but it's not less. Overall, it amounted to another decrease in the electricity bought from the system of about 2 or 3%.
So 8 plus 3.
Exactly, nice. Exactly. So overall, they got a environmental impact reduction of about 200 tons of CO2 equivalent per year.
Okay, so that's how you measure it.
Yes, exactly. The way to properly quantify the environmental impact reduction obtained by implementing an energy performance improvement action is also regulated by a number of methodologies. The most relevant one for Europe is the Economic Investment Bank one. They provide an annual methodology for determining the environmental impact in various industries, in depending on the form of primary energy that is used, etc. It's easily calculated, and every one of us can do that, even with respect to our private lives. You would be shocked to find out what our own carbon footprint amounts to.
Yeah, exactly. And that's very complicated to calculate. You have to take into consideration not only what your habits, but what you're eating, where are you traveling, if you travel. So all of the things. Yeah, that's another topic. Maybe we can dive into in another episode. But please tell me, is that true that the chiller is the biggest consumer of office building, for example?
Exactly. The heating, ventilation, and air conditioning system, which comprises of chillers, um, treatment units for the ventilated air, and so on, amounts to more than 50% of the energy use of a commercial building, may it be a mall or an office building or whatever. So
Yeah,
yes, that's true.
So if it's to just as an idea to compare the heat versus chilling versus heating, which is going to win in a contest of energy efficiency if it's to be electric?
Mm,
Hard to tell.
that's hard to tell because it depends on the specific energy boundary. Obviously, the overall efficiency is better if we use electricity for heating versus when we use it for cooling place. But on the other hand, for heating, we can also use natural gas. So even though it generates a potential higher environmental impact, when we look at it from a cost point of view, natural gas is 3 times cheaper than electricity. So for the same output, we can pay 3 times less. So that's a race electricity can't win, unfortunately, or at least not now. When natural gas will be forbidden, and that will happen by 2050, as the Green Deal aims at obtaining carbon neutrality by 2050 in all over Europe. So that means no natural gas, or that should mean no natural gas. Then electricity will start having an advantage against natural gas.
Okay, so is there a difference between energy efficiency and power quality? I mean, are those two kind of related, or what's the deal with it?
Yeah, so when talking about the energy performance regarding electricity use, power quality is a highly important factor of influence. The most commonly used power quality index is the power factor. This index tells us how much reactive energy we use compared to the active energy. Both of these types of energy are currently billed, so we pay for both the active energy and for the reactive energy. Uh, this
But
makes
you
power
basically,
fact.
sorry, you basically pay for the reactive energy, but it's kind of useless, right? And also it could be
It's
more expensive.
it could be more expensive. It's not useless, however. It is used to ensure the operational conditions of electric motors, of transformers, etc. But the fact that you end up buying it from the network costs you, and can cost you big. There are ways of mitigating this problem, which are the most common power quality improvement actions that are implemented in energy boundaries, and these are to install a so-called automatic power factor um, system, and this basically means that you install a capacitor bank which injects in your own grid the necessary reactive energy, so you don't buy it from the national power grid.
Yeah, so it
But
compensates. Yeah.
exactly. But this is where the mm, impact of power quality ends in the client point of view. But there are numerous other power quality indices which generate strong influence on the energy efficiency of the energy boundary. Another type of power quality indices that make or break the energy efficiency of a user is the total harmonic distortion. This basically translates in how well does our current curve or voltage curve resemble a perfect sinus curve. The more it goes towards a sinus curve, the better it is. When we have DC motors or inverters or any type of frequency converter, such as the before mentioned variable speed drive, which is basically a frequency converter, all these equipment generate disturbances in the power grid, in our power grid, and these disturbances then go in the national power grid.
Mhm. I see, but
Uh,
what's wrong with a non-perfect sine wave?
exactly, that's the issue. Mm, the main problem that these um, disturbances generate is the fact that they generate a parasitic current which travels throughout the power grid and leads up to an increase in temperature in electric lines, an increase in temperature in power transformers, malfunctioning of any type of electronic devices, and can also lead to a derating of the power transformers. This means that if we have a power transformer which is rated for, let's say, 2.5 megawatts, and we subject it to highly distorted current curves, it won't be able to offer us the 2.5 rated megawatts. Its
I see.
rated power, its actual power will drop below that rated power. And this could in turn lead to more in-depth problems such as the malfunction of the power transformer as it overheats, because the thing is that we don't use those currents. We don't actively use those currents. Those currents are higher frequency currents. So we use, as you know, in Europe, 50 hertz. That's the frequency of our power grids. These parasitic currents are currents which have a frequency of more than 50 hertz, 100 hertz, 150 hertz. So multiple values of 50. Okay.
Mhm.
We don't use them. We don't pay for them. They are not measured and built by the distribution system operator as reactive power is, but in turn they can lead us to worsening in the energy efficiency of the energy boundary, because as we've all know, when a electric current goes through a wire, any type of conductor, it generates heat in the form of Joule-Lenz losses. Yeah, these losses vary with the square of the intensity of the current that goes through them. The higher the current, the higher the losses. Two
Yeah,
times higher,
yeah,
actually. Two
yeah.
orders of measure
Physics is
higher.
physics, after all. Yeah,
Exactly.
but
Exactly.
let me get this straight. So we need perfect or kind of perfect sine waves also for current and voltage, right?
Yes.
Just because it's important for the equipment to have this quality. Let's call it quality energy, because otherwise it can be damaged or parts of it can be damaged. Did you encounter in your experience such equipment damage situations due to maybe messy inverters or I don't know, other type of perturbators in the network?
Actually, yes. I've met a client which is an industrial end user, and it operates a small plant in Romania, a small production plant in Romania, which uses lots and lots of DC motors. These DC motors are obviously powered up by a number of inverters. These inverters were generating tons of disturbances in the power grid. The, these devices were grouped up in a string of 10 devices for each power supply line. This this line was then powered up by a low voltage to low voltage transformer, because the client bought the devices from USA. He needed to provide the device with 120 volts, but the power supply in Romania is 230 volts. So he
Okay.
also used a low voltage to low voltage transformer.
Okay.
Because of the current harmonics, he ended up changing about 3 or 4 power transformers per month, because they would overheat, malfunction, and that's it. Game over.
So they're basically kind of reactive, right? They see problem. Oh my God, something is wrong with the equipment. This component is messed up. I need to fix it to okay. And then you see that the same component is messed up again and again and again. So then you
And
must ask, okay, it could be something wrong with the grid, right?
exactly. And the strange thing is that they didn't ask themselves that. They just continued to replace them. They ended up spending about 150,000 euros in
Oh my
less than
God.
2 years just for replacing small power transformers.
Yeah. Yeah.
Yes. So after we've audited the factory and identified that problem, which was a huge problem, consider the fact that the total harmonic distortion factor, which is a factor that quantifies all of the other higher frequency currents that I've mentioned before, 100 hertz, 150 hertz, up to the 15th power, uh, was 200% of the fundamental value of the current. So for every 100 amps of active useful power, they also transited 200 amps of parasitic currents.
Oh,
And
that's
they were
huge.
astonished that their power transformers were dying one after the other.
That's huge. Okay. So
We've
what?
recommend
Yeah. What
Yes,
recommended? Yeah.
we've recommended them to install active filters on the power supply of those production devices, production equipment. They did so, and since then, it's been 1.5 years, I think, they didn't change any transformer. So it's obvious the cause was the poor power quality. The main issue that can be concluded that is present throughout the industry is that the power quality indices are either not measured at all or are just ignored even if they are measured. The main reason for that is the severe lack of quality, power quality measurement systems, because most of the available measurement systems are bulky and are made for mounting on distribution boards or switchgear doors. They take up a lot of space, they cost a lot of money, and so most of the end users either don't install them at all or install just one, as I've said before, in the point of common coupling to analyze the overall power quality at the electric line or power transformer which powers up their entire energy boundary.
Yeah.
But it's not relevant.
Yeah,
It's not
because
relevant.
it's also a balance, right? How much you would invest in equipment to measure, and how much, what's the benefit, right? So it needs.
Exactly.
So in terms of, you said that about total harmonic distortion, right? Uh,
Yes.
is that enough? It's not enough. If not enough, what else do we need to know so that we understand, like have a better understanding of the power grid?
Great question. It's not enough. It's not enough by a long shot. We have, in order to get the best type of understanding of the performance of, especially an electric system, we have to know not only the quantity of energy it uses, not only the power factor and the total harmonic distortion, but also let's say uh, current imbalances, because most of our power grids, especially in the industrial sector and in commercial buildings, in shopping centers, in office buildings, are three-phased. But not all energy end users are three-phased. So there's a big task at hand here to properly balance the phases. We have to always have almost perfectly balanced loads on all three phases.
But if not,
Otherwise,
what's happening? Yeah.
exactly. Otherwise, we generate additional losses in our network. So even though we have LED lighting everywhere and the variable speed drive and the most performant tuning system and whatnot, in the end, the energy savings will not amount to the quantity that we hoped to get. Or in other words, the financial impact of the measure, of the action, will not be the predicted one. This in
Okay.
turn could lead to another mistake in understanding, because if the top management of a company expects to receive 100,000 euros by implementing this energy performance improvement action, they expect to get 100,000 euros as a net present value over the next 5 years, right? But because the the proper behavior of the network was not analyzed in a correct way, they'll end up getting 80,000 euros. Yeah. So they'll conclude that they will never invest in energy performance improvement again, because the expected results were not met. And
Yeah.
we all know that top management is mostly interested in financial indicators. Power quality has a great impact on the financial indicators alongside energy performance. I repeat myself, when we talk about electric end users, I dare to say that it's almost a 50-50 allocation in the overall results. You cannot take an energy performance improvement action without looking at the power quality, and you cannot take a power quality improvement action without looking at the energy performance of the boundary.
So yeah, but ideally speaking, if you have to imagine like something for of course we have systems to collect a bunch of data and put them in databases and stuff, but to truly understand the data, what's your ideal solution to see everything, like actionable insights all over the place, so that you as a professional, and not only professional but maybe a decision maker, business decision maker, you can act upon those data. So how do you envision this?
The ideal situation would be to have a properly designed measurement system. This measurement system doesn't have to only look at energy uses. Those are relevant, of course, but there are there are other factors that have to be taken into account when performing technical economic analysis of a certain energy performance improvement action. For example, I've mentioned earlier the commercial building with the chiller, right? A strong variable factor that influences the performance of the cooling system is the outdoor temperature, because obviously the chiller has to compensate for the heating produced by the sun, right?
That's true.
Warmer days, higher
Yeah.
consumption for the
Of course,
chiller.
there is also variable to how much the thermal inefficiency or efficiency of the
Exactly,
building is also to be taken
exactly,
into consideration.
exactly. Another important variable factor for the same chillers. How many clients does that commercial building usually has in a certain time frame, right? Because the more clients, the more need for cooling. The less clients, the less need for cooling. This derives from on one hand from the fact that by the simple presence of the clients, the air inside the building heats up, right? Because it exchanges energy with their bodies. And on the other hand, the simple fact that they enter and leave the building generates additional losses in the cooling or heating system. When the door opens, if they don't have a hot air, cool air curtain at the door, energy is lost.
Yeah.
For each client, a small portion of energy is gone.
So again, yeah, there are many variables. So how would you envision like something that truly answers and find like a solution for those kind of challenges?
The ideal solution would be to, as I've said, to implement a system which covers all forms of energy uses, from the point of common coupling or the fence, as we can call it, up to the most significant energy uses. For example, chillers, servers, highly energy intensive technological processes, if you're talking about industrial end users. Of course, we don't have to monitor when we're talking about car manufacturer, we don't have to monitor the smallest pump or motor that is used there.
Only the big consumers are kind of relevant in this.
Not necessarily the big. There can
Medium
also
to
be
big.
small consumers which are used 24/7.
Okay.
Maybe the big users are only used 2 hours a day. So even though they have 2 megawatts of installed power, if I have an additional, let's say, 200 kilowatts of installed power, which is way smaller than the 10 megawatts mentioned, but they are used 24/7, over the course of an entire year, they'll end up using more energy than the big consumer. So that's why I've used significant energy user and not the biggest energy users.
And
because it's not always the same.
Yeah, I understand. And is it more relevant for you like historical data or like real-time trends? If you have to choose.
That's a great, I'd like to not be put in the position to choose, because both those type of data provide valuable intel. Historical data can be used if properly measured with the proper frequency, in the proper conditions, in the proper points of measurement, can be correlated with variable factors, let's say outdoor temperature, to be able to get a full view of the performance of the system. Going back to that chiller that we've used as an example so many times already, if I knew how much electricity did it use over the past 3 years, let's say, and the variation of the outdoor temperature for the past 3 years, I could determine how good did it perform over time at the same temperature, because there would be scenarios in which the temperature was the same, right? So logically, we'd expect that if the temperature was 20 degrees today and 20 degrees last year today, the electricity consumption should be the same for the chiller. We might end up finding that it's not. And then this leads us to the idea that there is an additional variable factor which influences the energy use.
Yeah, it could be how many clients are there
exactly.
It could be it could be the sun for example, in the morning the angle is kind of special and hits the window in a certain way, and it provides heat inside. But if it's not sunny in that window and it's cloudy in that morning, then that's so that's also variable. Yeah, it's very interesting. One question regarding how would you see the overall trend, like in EU speaking, regarding this kind of topics? Is this trend of being more aware, right, of the energy consumption? Is this a responsible energy usage? Is this really a thing? How do you see that?
Yes, it is a thing, and by all means it should increase tenfold by the end of 2050, because if we aim to be carbon neutral, we have to take every single available step in order to achieve that goal. Keep in mind that most of the member states barely managed to hit their target set up by Directive 27, which was the former ultimate goal of the European Union. Most of them did. How well and how truly, that's not for us to discuss and to analyze. But in order to obtain carbon neutrality, which means that our overall carbon footprint has to be the same as it was in 1990, well, that's some ambitious goal. So in order for us to be able to reach that goal, we have to literally fight for it. So energy efficiency and energy performance improvement, by all means possible, by energy efficiency and by using renewable energy sources, is a must. So it's not only a trend, it's a must. It's let's say, our last chance for survival on the long term.
If not, we are populating other planets and we are good. But until then,
but yes, and and still, if we repopulate other planets, but don't adapt our mentality and don't learn the lessons that need to be learned from our experience on Earth,
we're just
it's
going
kind
to
of useless.
exploit them, and then that's
exactly.
it.
Rinse and repeat, and at a point in time, we'll run out of planets to repopulate.
Yeah, exactly. Yeah. We need a like a shift, like towards.
Yes, and the shift is happening. That's
Yeah.
that's a good thing, and the signs are all showing it. The shift is happening, and one of the best ways to convince unbelievers about the necessity of this shift is by quantifying it into money. Everybody understands money. Everybody
Talk me
understands
money,
cash.
and I understand.
Exactly. And the best way to achieve that goal is to develop, implement, and continuously improve the measurement systems in every energy boundary.
Yeah.
The better you measure energy flows, variable factors, etc., the better you can quantify their financial impact, and the better you can quantify the financial impact of implementing various energy performance improvement actions.
Yeah,
So
it's
that's a fact, and it's already starting to happen at a slow pace, at a slow rate, but it's starting to happen. Uh, Especially since ISO 5001 group of standards, which dictate how an energy management system should look, how it should be designed, how it should function, what the results should look like, how we should quantify those results, came into being. More and more companies are getting certified with ISO 5001 standard. And that is a big step towards carbon neutrality, if you ask me.
Yeah.
The more, the merrier.
Speaking about putting this into money so that people can understand and relate and be more sensitive to, I usually like to do this comparison, like think about your marketing campaign, yeah, but without measuring anything, without having a baseline, without having, so it's like blindly do something, like take some actions and don't understand if they are paying off or not. Is that good comparison or not?
Yeah. The best comparison, and unfortunately the end result is that the top management of a company chooses to not gamble. So as long as they cannot see or foresee the result, they prefer to step out, don't invest, don't take any energy improvement actions, and keep the business as usual model, right? Yeah. Which is not a great thing, but it's the truth. So it's up to us as energy auditors, and it's up to the employees of the client. May they be energy managers or technical representatives or facility managers, to properly inform the top management of the company regarding their energy improvement potential, energy performance improvement potential.
Yeah. Well, speaking of this, can you give us maybe like an advice for companies like in the manufacturing industry that maybe are small or even medium, that are kind of dealing with those challenges, but they didn't try to implement such systems so that they can benefit of the things that we just discussed? What's, I mean, if they are listening right to this, what's the key things that they could take so that they at least start their research or something?
Okay, so first and foremost, and that's not because I work in this energy auditing field, they should start with an energy audit done properly by the book. An energy auditor could help them understand the necessities of their own energy boundary. May it be technical necessities, like process-wise necessities, behavior-wise necessities, or measurement-wise necessities. Based on this audit, they can then start envisioning a system which would best satisfy them by themselves or by employing a specialized consultancy company to do that for them, with them, right? Another thing that I think should be further developed in this field is the use of IT, because as long as you have a raw database, you can't do much with it, right? You have 10 million data entries, so what? What can you do with them? I think that one of the most relevant advances in IT, it's not new for IT, but it's new for energy, uh, implementing machine learning algorithms in order to analyze big data sets, right? And in order to forecast future energy uses, future power quality issues, and so on, could also lead to a overall improvement of these systems and to overall improvement in the end, the financial profitability of the business. If I were to address to small manufacturers of measurement devices or sensors or any type of equipment used for measuring variable factors, energy flows, etc., I'd say that they should partner up and be able to deliver a full system, from the electricity meters to power quality analyzers to thermal meters, natural gas meters, any type of energy meters, sensors, up to the final software solution. Because if you deliver a full product, it's way easier to convince the top management of a company on one hand, and on the other hand, you have to take into consideration the fact that the European Union, up until 2020, and if you ask me, this will go on in the next financing period, financed energy measurement projects. So companies, uh, they had to be small to medium enterprises, were able to get up to 200,000 euros in order to implement energy measurement systems.
Yeah.
If one could provide the full solution, it could be profitable for the manufacturer, and it could be helpful for the final client. Because in the end, that's the goal, as I've stated in the beginning. The goal is to fight climate change. And we have to fight climate change at the source. And the source is energy uses. The more
Nice.
efficient we can make them, the better we are.
Excellent. So yeah, so that if I should sum up for this like industry, let's call it, it's like first do the audit. So just have a baseline, then keep on understanding what's happening now, and then add measures like low cost measures or maybe high cost measures that you want to implement, and then see and compare what was before and what is now, and understand if that is worth it or not, and try to measure your campaigns, marketing campaigns, right?
Exactly.
Okay,
That's
cool.
a perfect sum up.
Yeah. All right. So I think that's all. I would like to thank you very much for being here. It was a very productive conversation. So it's been a pleasure to have you start the Making Sensix of series, and we are looking forward to hearing again from you.
The pleasure was mine. Have a nice day.
Thank you.
Hey, special thanks to all those who watch our episode today. Make sure you subscribe to our channel to get notified for further episodes as well. If you find interesting topics you would like us to feature during the show, please drop us an email to say@sensix.io. Thank you very much. See you soon.